So we wanted to test centripetal force, but we realized doing this experiment with a bucket does not increase centripetal force, it only increases arm power.
Centripetal force is a force that always moves towards the center of the circle. When too much centripetal force is applied, the object will fall in towards the center, no longer going in a circular motion. When too little centripetal force is applied, it will fly off at a tangent, no longer going in a circular motion. A tangent is a line that touches the circle and flies in the direction that the circle is going at that point. Therefore, to create a circular motion with any object, you need the correct centripetal force, not too much and not too little. Things that affect how much centripetal force an object needs are the mass of the mass of the object. Mass goes up, that means the centripetal force has to go up. The speed of the circular motion. Faster spinning needs more force to keep spinning.
First, we measured the minimum speed that the water could stay in the jug at. After, we measured the minimum speed and we measured the time it took to do 3 rotations. We timed 50 mils at 2.37 seconds and we divided that by 4.5, which we got from the circumference of the circle times 3. That gave us our answer of 0.526 meters per second. Our equation was time divided by distance equals speed.
Over here we did 100 milliliters of water. We noticed that we had to apply more centripetal force to actually keep the water in the jug. Our result was 0.493 meters per second.
Next, we are doing 150 milliliters of water. In this one, even more centripetal force was needed to keep the water in. Our results was 0.475 meters per second.
Lastly, we have 200 milliliters of water. This one, as the trend in the others, we needed more centripetal force. Our result was 0.453 meters per second. In conclusion to this experiment, we observed that when the mass goes up, the meters per second goes down. So in this case, water falls out when we did not apply enough centripetal force, and that's why I'm wet over there.
As you can see here, we have a dirty coin. This coin is dirty due to something called copper oxide, which forms over the coin. Copper oxide forms because the copper in the coin reacts with the moisture in the air.
These are the things we need to make our 3 solutions that we will put our coins into.
Here, we are mixing 2 tablespoons of salt into a glass of water for our first solution. For our second solution, we are mixing a glass of lemon juice and putting in 2 tablespoons of salt. Lastly, we are mixing 1 glass of vinegar with 2 tablespoons of salt for our last solution.
Now that we have finished our 3 solutions, we're going to drop the 3 10-cent copper coins in the solutions.
We have waited about 5 minutes and now it's time to take all 3 coins out of the solution. The result of the experiment was the copper 10-cent coin in the vinegar was the most corroded and faded. The coin in the lemon juice was a little faded in color, however was not as corroded as the coin that was in the vinegar.
The coin in water was cleaned a bit, however not faded or corroded even slightly compared to the vinegar and the lemon juice.
The vinegar and salt solution worked the best because of the sodium chloride in the salt combined with the acetic acid from the vinegar to produce sodium acetate and hydrogen chloride. Hydrogen chloride is an extremely strong acid, and the combination of this and sodium acetate rapidly dissolves the copper oxide on the coin, making the surface extremely clean.
Swag.
For our last experiment, we are testing the density of different objects. We are testing the density of a sponge, a piece of paper, and tinfoil.
Almost instantly, the water is absorbed into the sponge because it has a low density and the water has a lot of places to go. This is due to the molecules in the sponge being quite far apart.
Next, as I put a spoonful of water onto the paper, most of it rolls off as only little is absorbed. This is because the water has a place to go inside the paper, but still has a quite high density.
Lastly, with the tinfoil, the water just runs off because it has a high density and the water has nowhere else to go. This is because the molecules in the tinfoil are very compact.